All right. So this is our question at hand. What polynomial has roots of 6 and 3i? All right. So what we're going to do is we're going to come up with some polynomial like x cubed minus 4x squared plus 6x minus 1. And we want this polynomial to have these two guys as roots. Now, a root is it's just another word for solution, really. This means that if I take the number 6 and plug it in for x, I should get 0. That's what a root is. Or if I take the number 3i and substitute that in for all the x's, I should get 0. So that's the question, is what polynomial will have these two roots, these two numbers as solutions. So to figure that out, we're going to need something called the complex conjugate root theorem. All right. This is what's going to get us started here. It says that complex roots have to come in pairs. Okay. So if you have some polynomial p, and if you know that a plus bi is one of the solutions, then so is its conjugate, a minus bi. It's just that thing where you change the middle sign, right? That basically means that when you have an imaginary solution or an imaginary number as a solution, then its conjugate is also going to be one of the solutions, okay? So I know the problem says what polynomial has these two numbers as roots, but this implies that there is a third number, okay? Because you can't just have 3i as one of your answers. Negative 3i is also a solution. All right, so these three numbers are going to be solutions to the polynomial that we're going to create here. To create the polynomial, what I'm going to do is I'm going to first write it in factored form. Okay, if 6 is a solution, then x minus 6 is a factor. Okay, notice if you plug in 6 for x, you get 0. That's a root. That's a solution. That's what corresponds to that. If 3i is a root, then x minus 3i is a factor. And if negative 3i is another root or solution, then x plus 3i is the factor that corresponds to that. So you got three solutions, you got three factors, okay? And then what we're going to do is we're going to multiply this whole thing out. All right? You cannot, unfortunately, we cannot just throw this into the calculator. We can check our answer with a calculator, but the calculator will not multiply this out for us. This is going to involve a lot of the distributive property, a whole bunch. All right, so the reason that we like conjugates is because of what happens when you multiply two conjugates. All right, if I multiply these two things, the imaginary parts are going to disappear, thankfully. So what I'm going to do is I'm going to multiply these two first. I'm going to bring down my x minus 6 and go ahead and multiply these. So x times x will be x squared. X times 3i will be 3ix. And then I'm going to do the negative 3i times x, negative 3ix, and negative 3i times 3i, which would be negative 9i to the second power. Okay. So I said that the imaginary parts were going to disappear. Here you see that these are just going to cancel out, positive 3ix and negative 3ix. Now over here, this is something you'll have to pay close attention to. The I squared, if you recall when we talked about I, we said it was equal to the square root of negative 1, and we said that I to the second power was just flat out negative 1. And that's what I'm going to do here. I'm going to substitute the negative 1 in for the I squared. So this is like negative 9 multiplied by negative 1, which is going to turn this into a positive 9 right here. Okay. So this whole piece is going to become x squared plus 9 And then I still have that x minus 6. And I got to keep multiplying it out, keep distributing. All right, x times x squared is going to give me x to the third. X times 9 will give me 9x. Negative 6 times x squared gives me negative 6x squared. And then negative 6 times 9. All right, last thing I'm going to do here is just rearrange this so it's in standard form. So my answer is x to the third minus 6x squared plus 9x minus 54. That's it. This is the polynomial that has 6 as a root and 3i as a root. So if I take the number 6 and plug that in for x, it's going to drive this thing to 0. Okay. Right, if I do 6 stored to x cubed minus 6x squared plus 9x minus 54, you see that it gives you 0. And same thing goes if I plugged in 3i. 3i stored to x, and that's also going to give me 0. Okay? So the way you set it up is you're going to, if they give you an imaginary root, you're going to write its conjugate as a root as well, because they have to come in pairs. All right, and then what I did was I took these 3 solutions and I wrote their corresponding factors. 6 was a root, x minus 6 was a factor. 3i was a root, x minus 3i was a factor, and so on. All right, I'll do another example here in a sec.